Hi student, my name is K. Narash, working as a assistant professor in the Department of Civil Engineering. So today I am explaining about water treatment. It is a part of the environmental engineering in our unit 2. So first of all, this water treatment which is suitable for the not fresh water, that is suitable for polluted water. So at the initial stage, the availability of the water is very pure. So coming to the during the precipitation, so the water is get polluted by attracting the surrounding atmospheric gases and dust particles. So that water is converted into a polluted water. So that's why that water is not suitable for the consumption for the domestic purpose or industrial purpose or any other purposes. So that's why, so before consumption of the water, that water is going to be treatment. So in this treatment, so first of all, what are the objectives to get achieve from the to get from the water treatment. So in this water treatment, so first, to remove the color and turbidity and dissolved gases of water. So this color in the presence of the colloidal particles, this turbidity is the presence of the suspended solid. So this suspended solids, the particle size varies between the 10 to the power of minus 1 to 10 to the power of minus 3 mm. These colloidal particles which gives to the color to the water, so in the range of the 10 to the power of minus 3 to 10 to the power of minus 6 mm. So second one is to remove the objectionable taste and odor. This 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 objectionable taste and odor, the water it gives the dissolved gases. So this taste and odor in the presence of the dissolved gases such as a CO2 and hydrogen sulfate. So third one is to remove the disease producing microorganisms so that water is safe for drinking purposes. So in this diseases producing cause due to the presence of the pathogenic bacteria. So pathogenic bacteria means, so this bacteria which cause the diseases, that is called as a pathogenic bacteria. So like like bacteria, virus, fungus and protozoa. So these are the example for disease causing bacteria. Third, fourth one is to remove the hardness of water. So hardness of water, which is due to presence of the chlorides and nitrates and carbonates and sulfates of the calcium, magnesium. So if the hardness of the water is more, so then that water is not suitable for the drinking purposes. So these are the objectives of the water treatment. So the next is going to be stages of the water treatment. So in the stages of the water treatment, so initially the raw water is taken from the surface sources through with the help of the intake structures. So intake structures means the water is collection from the source to deliver to the treatment units. So directly water is driven from the source. The next stage will be screening. After the screening, next stage will be aeration. The next, after aeration, next stage is flocculation. After flocculation, next stage is sedimentation. After sedimentation, filtration process is there, and after filtration, disinfection process are there. After disinfection, softening process are there. So in this detail, so first stage is screening. So this screening is adapted to remove all the floating matter from the surface water. So it is generally provided the in front of the intake point. So floating matter, examples polythene covers and organic matter and branches of the trees and plants and the roots of the plants and trees. So in this screening process, which are placed at the in front of the intake structures in the screening, so there are the two types of screens are there. So first one is coarse screen. So this coarse screen placed in front of the fine screen. It is consist of the iron rods placed vertically or inclined at the 45 to 60 degrees. So if the screen is placed at a 90 degrees, so there is a possibility to move to the screen. So that's why, so always screens are placed inclined to the flow of water at 45 to 60 degrees. So in this cross screen, the dia of the screen is so 20 to 100 center to center distance, and so dia is 20 to 25 diameter. So by using these coarse screens, so the clogging is not frequently. So that's why the most of the sites we have to use these coarse screens for removal of floating matter. So now coming to fine screen. So if it is consist of the wire mesh, and also it removes the fine materials, and fine screens get clogging easily and to be cleaned frequently. So by using the fine screens, so the diameter of the fine screen is 6 to 10 diameter screens are there. So by using the fine screens, so clogging is frequently. So when the clogging is frequently, so at that condition, so cleaning also so frequently, so it will take the more time to clogging and more time to so cleaning. So that's why we are using in and real time. So coarse screens are better to use to removal of the floating matter. So you have to see clear images to the clean coarse screen and fine screen. So these screens are placed across to the flow of water at incline 45 to 60 degree 60 degrees. So when the using inclined, so to increase the flow area at the upstream side, and also the velocity of the water will be decreases. That's why screens placed at inclined to the flow of water. So now coming to the second stage, that is aeration. So this aeration is often the first major process at the treatment plant. So it is the initial process. So this method is optional. So this method also is most suitable for the underground water. Why? Because so the underground water, so it does not contact with any atmospheric pressures. So on the, for example, we take surface water, lakes or rivers or ponds. So that the water bodies already it contact with the water. So that's why no need to so aeration process. So that's why this method is most suitable for the underground water. So this is adapted to remove the objectionable taste and water, and also to remove the dissolved gases such as a carbon dioxide and hydrogen sulfide and volatile organic chemicals. So in this process, so the raw water is brought instant to the air. So instant to the air. So the raw water is closely contact with the air. So that is help to remove the dissolved gases. So the picture is clearly shows that so aeration, the water is, so thus the aeration is cascade aeration. So one of the so type of aerator. So in this diagram, so the water is flow free from the so step by step. So thus result in the so water is directly contact with the so air. So this is process is known as a aeration. So in this aeration, there are the different types of you aerators are there. So first one is spray nozzle aerator. So in this spray nozzle aerator, so this aerator which is used to remove the so dissolved gases such as a sulfur dioxide, such as a hydrogen sulfide and carbon dioxide. This cascade aerator, so which is also used to remove the dissolved gases such as a hydrogen sulfide and CO2. So this spray nozzle, the efficiency is 100% to remove the CO2 and the efficiency of the 99% to remove to the H2S. So this method is very costly. That's why we are not using in our treatment units. Treatment unit. Second one is cascade aerator. Cascade aerator, it is simply known as a step aerator. So these steps are made above with RCC, and this method is also cheap and economical. So this method is simple uses and most of the treatment units by using the cascade aerator. So in this method, so the efficiency of the removal of H2S and CO2 is very low compared to the spray nozzle aerator. So third one is diffused air aerator. So a diffused air aerator is removed to the objectionable taste and odor. Objectionable taste and odor. In this diffused air, so the detention time is 15 minutes. So next one is trickling bed or tray cover aerator. So in this trickling bed, so we use coke bed. So when the water is flow free from the tower aerator, so the water is going through the coke pit. So that's why the removal of the dissolved gases, iron and magnesium and hydrogen sulfate. So when the compared to the this method is most suitable for the low categorized industries and low categorized industries. So that's why the efficiency of the tray tower aerator is greater than the cascade aerator. So these are the types of aerator. Now going to be next stage, that is sedimentation. So in this sedimentation, the separation of the suspended solids to settle down by the gravitational is called as a sedimentation. So this sedimentation occurs when the particle size is heavier than the water. So that's why in that cases the suspended solids are settled at the bottom of the tanks. So these sedimentation tanks are designed to reduce the velocity of flow of water, so that to permit the suspended solids settle out in the water by the gravity. So in this sedimentation, it can be classified into two types. First one is plain sedimentation and second one is sedimentation with coagulation. So you clearly observe that. So first diagram shows the sedimentation tank. So this sedimentation tank HRT with inlet and outlet. So the raw water is coming through an inlet. So after reaches the end point, so the suspended particles are settled down at the bottom of the tank. So the picture view of the second image shows particles suspended in water and particles settled in bottom. At between time taken, the time taken is called as a detention time. So in this plain sedimentation, it is the process of settle down of solids and impurities in the raw water to the bottom of the sediment basin by the natural gravity force alone. So there is no chemical is added. That is called as a plain sedimentation. This method is very cheaper and mostly used in the all filtration and purification system of water. So next stage is coagulation. So in this coagulation, the turbidity is mainly due to the presence of the very fine colloidal particles and organic matter. So the other alternative to remove such as a particle to increase their size and that they become the settleable. The purpose of the coagulation thus make to particle of the bigger size by adding certain chemicals is known as a coagulants to the water. So the chemical components is added to the water, that is called as a coagulant. So this coagulant added to the water, that process is called as a coagulation process. So this coagulation process is to be adapted when the turbidity of the water exceeds about 40 ppm or mg per liter. So next stage is filtration. So filtration is the process in which solid particles in a liquid or gaseous fluids are removed by using the filter media, so that allows to the fluid to pass through while retaining the solid particles. So in this filter media, it is made up of a sand particles and quartz aggregate with the size of the 20 mm and with the size of the 40 mm and greater than the 40 mm. So in this filter media, it may means use of physical barrier and chemical and biological process. The removal of the particles takes place with the process of including straining and flocculation and sedimentation and surface capture. So in this filtration helps to in removing color and odor and turbidity and pathogenic bacteria from the water. So in this filtration, so there are the two types of filters are there. So first one is slow sand filter and second one is rapid sand filter. So slow sand filter and rapid sand filters. So similar to same the working principles, but there is a difference between the cleaning process. So slow sand filter is cleaning by the manually and rapid sand filter in cleaning by the backwashing, so automatically cleaning. So next stage is disinfection. So it is necessary to disinfect the water to kill the bacteria and other microorganisms. So in this disinfection means destruction or inactivation of the harmful substances which present in the water. So these chemicals added for the killing harmful substances is known as a disinfect, and the process of the killing the bacteria is known as a disinfection of water. So in this disinfection of water, so we most use of chlorine. So the chlorine with the help of the under the efficiency of the by using chlorine is 100% to removal of the killing bacteria and other microorganisms. Last one is the last stage is softening. So in this softening, it is the process of removal of hardness from the water is known as a softening. So hardness can be classified into two types: temporary hardness and permanent hardness. So this temporary hardness is due to the presence of the chloride carbonates and carbonates and sulfates of the calcium and magnesium, and this the permanent hardness is due to the presence of the chlorides and nitrates of the calcium and magnesium. This temporary hardness is removed by using of the boiling method, and this permanent hardness is removed by the using of ion exchange method and zeolite method and demineralization method. So in this hardness of water, the permissible limit is 75 to 200 ppm. If the hardness of water is about 75 that water is known as a soft water. So the permissible the hardness of water is in the range of 75 to 200 ppm. So that water is known as a moderate water. So the hardness of the water is greater than the 200 ppm. So that water is known as a hard water. So this is there are the different stages of water treatment. After the all these stages completed, so that raw water is successfully distribute the fields. Thank you.